Welcome back. In this section, we will learn about evolutionary search. In this section, we'll cover the following videos. First, we'll see the puzzle which we will solve in this section. We will also learn the main ideas behind evolutionary search. After that, we will learn what is a population and how to represent an individual of a population. Then we will learn how to evaluate the fitness of an individual and how we can select them for reproduction. Later, we learn how to create a new set of individuals using reproduction in evolutionary search. After that, we will learn how to stop reproduction and get the solution for N Queen's puzzle. After these 5 videos, you would have got a good idea of evolutionary search. So you will try to develop another application by yourself. Finally, we will discuss the advantages of evolutionary search over other search methods. In this video, we will see the puzzle that we will solve with evolutionary search. In this video, we will learn about N Queen's puzzle, understand the basic ideas behind evolutionary search, and the flow of evolutionary search. In N Queen's puzzle, there is an n by n chessboard, and the aim is to place N queens on the board so that no queen attacks another queen. Note that queens attack each other horizontally, vertically, and diagonally. So no 2 queens should be in the same row, column, or diagonal. We can solve this puzzle using constraint satisfaction problem search, but we might have to check many combinations before we arrive at the solution, even if we use heuristics. Instead, we can use evolutionary search. Evolution is the change in characteristics of a population over generations. Evolution favors traits suited for survival. It is used for explaining the changes of apes into humans. Charles Darwin wrote the phrase survival of the fittest in his book Origin of the Species to describe the natural selection process happening in nature. According to this theory, fitter individuals will last longer to pass on good traits to the next generation. Suppose there are 2 types of bugs living on red flowers, maroon-colored bugs and blue-colored bugs. The maroon-colored type is fitter than the blue one because it is able to camouflage itself against the red flowers, and in this way it is able to protect itself from predators. Therefore, maroon bugs will survive longer than the blue ones to pass on their traits to the future generations. So in the future, there will be more maroon bugs than blue, since that is the trait which is favored by the environment. In evolutionary search, the population consists of potential solutions. So instead of organisms, we have potential solutions. A better solution has higher chances of passing on its traits to the next generation of solutions. Let's look at the overall flow of evolutionary search. We first initialize a population of solutions. We check if a particular condition is satisfied. If it is not, then we produce children which make up the population in the next generation, and we carry on until the condition is satisfied. When the condition is satisfied, the solution is the fittest individual. So we need a way to evaluate the fitness value of individuals. Now let's see how children are generated. We use biologically inspired functions: selection, crossover, and mutation. We select 2 parents based on fitness. The higher the fitness of a solution, the higher its chance of getting selected to create a child. We cross them over to create a child, and then we mutate it. We will look at all these components in detail in the upcoming videos. Let's recap what we learned in this video. We learned about the constraints of N Queen's puzzle, and we looked at the main ideas behind evolutionary search.